Hello students, in this video I am going to explain you the concept of pigeonhole principle. This is an amazing concept. Now we are going to understand what exactly pigeonhole principle is. According to this concept, if there are n number of boxes and n plus 1 number of pigeons are there, then there must be at least one box that contains more than one pigeon. Now here what we have find? We have find total number of boxes are 9 and number of pigeons are 10. So what we find? We find this box has more than one pigeon. This theorem has a very wide scope in mathematics. Now we are going to apply the concept of pigeonhole principle to solve various problems. Now, application of pigeonhole principle. Now, prove that any 10 points selected within a square of side length 3 cm, there are 2 of them which distance apart is at most root 2 centimeter. We are going to apply pigeonhole concept to solve this question. How many points we have to mark inside a square? We have to mark total 10 points. What we have done here? We have simply divided the square into 9 equal parts. Each part has dimension 1 into 1. This means the length is 1 centimeter and breadth also is 1 centimeter. If you mark every point inside one square, so suppose you marked 1 point inside this square, 1 point inside this square, 1 point inside this square. If you marked in the same manner, you marked 1 point inside every square, what you find? You have marked total 9 points, and how many points you have to mark? You have to mark 10 points. So what we find, at least one square is there that contains more than 1 point. More than 1 point, it means at least one square contains 2 points. And what is maximum distance between the diagonals of 1 into 1 square? That distance is root 2 centimeter. So this is an amazing idea. Now, second question is that application of pigeonhole principle. Second question is that prove that any set A of 7 distinct real numbers, there exist x and y belongs to A such that x minus y 1 plus xy edge lies between 0 to 1 by root 3. Now I am going to solve this problem by using the concept of pigeonhole principle. Now let us draw a line. We have taken a line OH origin. This is pi by 6, this is pi by 3, and this is pi by 2, minus pi by 6, minus pi by 3, and minus pi by 2. So interval there is from minus pi by 2 to pi by 2. So what is length of total? Total line is this pi minus pi by 2 to pi, each pi by 2 is pi. And we have divided this into 6 equal parts. So this is 6 equal parts. Suppose this is box 1. Let us suppose this is box number 2. Mark this with P2. This is box number 3. This is box number 4. This is box number 5. And this is box number 6. Now, length of each part is pi by 6. Now, let us suppose that x is equal to tan alpha and y is equal to tan beta. We know that in minus pi by 2 to pi by 2, both tan alpha and tan beta is increasing function. The value of tan alpha and tan beta lies from minus infinity to plus infinity. Now, what we need to prove? We need to prove that x minus y whole divided by 1 plus xy this means if you put x as tan alpha and y as tan beta, what does it mean? Tan alpha minus tan beta whole divided by 1 plus tan alpha tan beta. This is what? This is x minus y upon 1 plus xy. And this is equal to tan of alpha minus beta. So what we need to prove? We need to prove tan of alpha minus beta is 0 to 1 by root 3. Now what we need to prove? We need to prove alpha minus beta is from 0 to pi by 6. Now we have divided the total minus pi by 2 to pi by 2 into 6 equal boxes. Say this is box 1, box 2, box 3, box 3, 4, 5 and 6. And length of each box is pi by 6. This length is pi by 6. This length is pi by 6. Length of each box is pi by 6. Now what we have to do? We have simply put 7 different real number in 6 boxes. So what we find is at least one box is there that contains more than one number, and length of that interval is pi by 6. So by using pigeonhole principle, we simply derive this result. Thank you and see you in next video.